Hello everyone, myself Vinay Kumar. I am actually pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my last video, I was actually discussing the first chapter of 8th standard mathematics. So that is rational numbers. So I have actually discussed what is whole numbers, natural numbers, integers and rational numbers, and I have also discussed about commutative property and closure property under addition, multiplication, subtraction and division. So if you want to learn that particular concepts, then please go to my first part of this particular rational numbers. So this is second part of rational numbers, where I will be discussing associative property and other properties related to this particular chapter. So now let us discuss whether associative property under addition, subtraction, multiplication and division is satisfied by whole numbers, integers and rational numbers or not. So now first let us discuss associative property. So first we will be discussing associative property under addition for whole numbers. So let us see whether associative property under addition for whole numbers is satisfied or not. So now let us consider 0, 2 and 3 as our examples for whole numbers. Now for associative property under addition, there is a condition. A plus of B plus C. That is, this B plus C should be inside bracket and this A should be outside bracket, where A plus of B plus C should be equal to A plus B. Here actually A plus B will come inside bracket and C will go outside bracket. So A plus of B plus C should be equal to A plus B of plus C. So if this particular condition is satisfied by whole numbers, then associative property under addition for whole numbers will be satisfied. Now let us go on testing for this 0, 2 and 3, because 0, 2 and 3 are whole numbers. So 0 plus 2 plus 3. Here 2 and 3 are B and C. 0 is A. So 0 is outside, 2 and 3 are inside bracket. So first you should solve the numbers which are there inside brackets according to BODMAS rule. So BODMAS rule you might have learnt in your previous classes. So 2 plus 3 will be 5. So first you just add them. So 5 will be the answer. Now it is 0 plus 5. So 0 plus 5 is again 5. Now you just write the 0, 2 and 3 in this form, like whatever is there in this particular RHS of this particular equation. So 0 and 2 will come inside bracket. So plus 3 will go outside. So 0 plus 2 is 2 plus 3 will be there as it is. So now 2 plus 3 is 5. Here also you are getting answer 5. Here also you are getting answer 5. That shows 0 plus of 2 plus 3 is actually equal to 0 plus 2 plus 3. That means this particular associative property under addition equation is actually satisfied by this particular whole numbers. So associative property under addition for whole numbers is actually satisfied. Similarly, if we are testing associative property for subtraction, under subtraction for this particular whole numbers, let us take the same example 0, 2 and 3. So now here the equation will be A minus of B minus C should be equal to A minus B of minus C. So when the whole number satisfy this particular equation, then only associative property under subtraction can be satisfied. Let us see whether they are satisfying or not. So 0, 2 and 3 will be your A, B and C. So 0 minus of 2 minus 3. So I am writing in the form of LHS. So 0 minus of 2 minus 3. First you should solve inside bracket. So 2 minus 3 will be minus 1. So here 0 minus of minus 1 is your answer. So when you solve this, minus into minus will become plus. So that's why you'll get 0 plus 1. That the answer for 0 plus 1 will be 1. Again, if you write this 0, 2 and 3 in the form of RHS, let us see whether you are getting same result or not. So 0 minus 2 will be inside bracket, minus 3 will be outside bracket. So first you should solve inside bracket. So 0 minus 2 will be minus 2 and minus 3 will be there. So minus 2 minus 3 will be minus 5. So when you write in the LHS form, you are getting 1 as the answer. When you write in the RHS form of this particular equation, you are getting minus 5 as your answer. That means 0 minus 2 minus 3 is not equal to 0 minus 2 of minus 3. So that shows a plus b, a minus of b minus c is not equal to a minus b of minus c. That shows associative property under subtraction for this particular whole numbers will be not satisfied. So now let us check associative property under multiplication for this particular whole numbers. So let us take the same example 0, 2 and 3. So here the equation will be a into of b into c is equal to a into b of into c. So this will be the equation for associative property under multiplication. Now let us consider 0, 2 and 3 as ABC since 0, 2 and 3 are whole numbers. So 0 into of 2 into 3 will be like first you should solve inside bracket. So 3 into 2 is 6. So 0 into 6, 0 into 6 is 0. Now 0 into 2 will be inside bracket and 3 will be outside bracket. So 0 into 2 is 0. So 0 into 3. So 0 into 3 will be 0. So here also you are getting 0. Here also you are getting 0. That shows 0 into 2 into 3 like 0 into 2 into 3 where 2 into 3 are in bracket is equal to 0 into 2 of into 3. 3 is outside bracket is actually equal. These both are equal. That shows a into b into c is equal to a into b of into c. So this particular equation is actually satisfied by this particular whole numbers. That means associative property under multiplication for whole numbers is actually satisfied. Coming to the division of associative property, like associative property under division for this particular whole numbers. So let us consider 0, 2 and 3 as our example. So here a divided by of b divided by c should be equal to a divided by b of divided by c should be outside. So if this particular condition is satisfied, then associative property under division will be satisfied. Let us check whether these whole numbers are satisfying or not. So 1 divided by 2 divided by 3. So here first you should solve what is there inside bracket. So 1 divided by 2 by 3. Now you can change this divided by into symbol. So you can change this division into multiplication and you can interchange this second number with numerator and denominator. So 2 by 3 will become 3 by 2. So the answer 1 into 3 by 2 will be 3 by 2. Now let us write in this RHS form. So 1 divided by 2 divided by 3 will be outside. So now it will be 1 by 2 divided by 3. Now 3 is actually 3 by 1. So now you can change this division into multiplication and it will become 1 by 2 into, and you should change this numerator and denominator. So it will become 1 by 3. 3 by 1 will become 1 by 3. So 1 into 1, 2 into 3 will be 6. So when you write in the form of LHS, you are getting 3 by 2 as answer. When you write in the form of RHS, you are getting 1 by 6 as your answer. That means 1 divided by 2 divided by 3 is not equal to 1 divided by 2 of divided by 3. So that shows this particular equation is not satisfied by whole numbers. So associative property under division for this whole numbers is not satisfied. So coming to the conclusion part of this associative property for whole numbers under addition. So addition is actually satisfied. Subtraction is actually not satisfied. Multiplication is actually satisfied. Division is actually not satisfied for this whole numbers. Now let us test this associative property under addition, subtraction, multiplication and division for integers. So associative property of under addition for this particular integers, whether integers will satisfy or not. So let us consider minus 1, 1 and 2 as 3 integers. So here also the equation will be same like whatever I have written previously. So a plus of b plus c is equal to a plus b of plus c. So this particular equation should be satisfied. So let us see whether integers will satisfy or not. So minus 1 plus of 1 plus 2 will be equal to, first you should solve inside bracket. So minus 1 plus 2 will be 3. So minus 1 plus 3 will be plus 2. Now minus 1 plus 1 will be inside bracket. I am writing in the form of RHS of this particular equation. So minus 1 plus 1 in outside bracket there will be plus 2. Minus 1 plus 1 will be 0. So 0 plus 2 will be your answer, like 2 will be your answer. So here also you're getting 2 as your answer, here also you're getting 2 as your answer. That means minus 1 plus of 1 plus 2 is actually equal to minus 1 plus 1 of plus 2. So that means this particular equation for associative property under addition is actually satisfied by integers. So associative property under addition for integers is satisfied. Similarly, associative property for subtraction for this particular integers, let us check whether it will satisfy or not. So associative property under subtraction has an equation a minus of b minus c should be equal to a minus b of minus c. Then only this particular associative property under subtraction will be satisfied. So now let us take minus 1, 1 and 2 as our example for integers. So let us write in the form of LHS, that is minus 1 minus of 1 minus 2 will be inside bracket. So first solve what is there inside bracket. So 1 minus 2 will be minus 1. So minus 1 minus of minus 1, because here it will be minus 1. So minus is as it is written here. So minus 1 minus of minus 1. So here minus into minus will become plus. So minus 1 plus 1. So minus 1 plus 1 will be 0. Similarly, if you write in the form of RHS, then a minus b will be minus 1 minus 1, that will be in bracket, minus this the other number is 2. So 2 will be there. So if you solve what is there inside bracket, so minus 1 minus 1 will be minus 2 minus 2. So minus 2 minus 2 will be minus 4. So here when you solve this particular integers by putting as LHS, like whatever LHS is there in this particular equation, in that form if you are putting these three integers, then you are getting 0 as answer. If you are putting the these particular integers in the form of RHS, then you are getting minus 4 as your answer. So here it shows minus 1 minus of 1 minus 2 is not equal to minus 1 minus 1 of minus 2. That means this particular equation is not satisfied by this integers. So associative property under subtraction for integers is not satisfied. Now let us check associative property under multiplication for this particular integers. So let us take minus 1, 1 and 2 as our example for integers. So the equation will be a into of b into c is equal to a into b of into c. So this particular equation should be satisfied by these three integers. So now let us write in the form of LHS. So minus 1 into 1 into 2. So here minus 1, 1 and 2 acts as a, b and c. So first let us solve inside bracket. So minus 1 into 1 into 2 is 2. So minus 1 into 2 will be minus 2. So now let us write in the form of RHS. So minus 1 into 1 will be inside bracket into 2. So minus 1 into 1 will be minus 1 into 2. So minus 1 into 2 will be minus 2, because minus into plus will be minus, 1 into 2 will be 2. So minus 2 is your answer. So when you write in the form of LHS, you are getting minus 2. When you write in the form of RHS, also you are getting minus 2. That means minus 1 into of 1 into 2 is equal to minus 1 into 1 of into 2. So that shows this particular equation is actually satisfied by these integers. So associative property under multiplication for integers is satisfied. Similarly, associative property under division for these integers, let us check whether it will satisfy or not. So minus 1, 1 and 2 will be the example for integers, and the equation will be a divided by of b divided by c is equal to a divided by b of divided by c. So this particular equation should be satisfied. So let us write in the form of LHS, minus 1 divided by of 1 divided by 2. So this will be minus 1 divided by 1 by 2. So minus 1 divided by 1 by 2 will be, so now I can interchange this division into multiplication by interchanging this numerator and denominator of the second term. So minus 1 into 2 by 1. So minus 1 into 2 by 1 will be minus 2. So now let us write in the RHS form. So minus 1 divided by 1 will be inside bracket. So divided by 2 will be outside. So minus 1 divided by 1 will be minus 1. Divided by 2 will be outside. That is actually minus 1 by 2. So when you write in the form of LHS, you are getting minus 2 as answer. And when you write in the form of RHS, you are getting minus 1 by 2 as your answer. that shows minus 1 divided by 1 divided by 2 is not equal to minus 1 divided by 1 of divided by 2. So this particular equation for associative property under division is not satisfied by this particular integers. So associative property under division for integers is not satisfied. Now let us test this associative property for rational numbers. So first let us do associative property under addition for this particular rational numbers. So let us take easy rational numbers. Let's say 1 by 1 and 1 by 2 and 1 by 3. So these three are three rational numbers which I am taking as example, and the equation for associative property under addition will be a plus b of b plus c, a plus of b plus c is equal to a plus b of plus c. So this particular equation should be satisfied for associative property under addition to get satisfied. So 1 by 1, 1 by 2, 1 by 3 are three rational numbers. So 1 by 1 plus of 1 by 2 plus 1 by 3 should be solved. So when you solve 1 by 2 plus 1 by 3, you will get 5 by 6 as answer. So 1 plus 5 by 6 you will get as answer. So when you solve 1 plus 5 by 6, again you should consider this as 1 by 1. So here you should take LCM of 1 and 6, that is denominator. So the LCM will be 6. So after solving this, you will actually get 6 plus 5 divided by 6. So 6 plus 5 divided by 6 will be 11 by 6. So similarly, if you write this in RHS form, you will get 1 plus 1 by 2 inside bracket. Outside there will be 1 plus 3, 1 by 3. So 1 plus 1 by 2 will be 2 plus 1, that is 3 by 2 plus 1 by 3. So when you solve this 1 plus 1 by 2, you will get 3 by 2 as your answer, and plus 1 by 3 will be there outside. So now if you want to solve 3 by 2 plus 1 by 3, then you should take LCM of 2 and 3. So that will be 6. So 3, if you multiply this with LCM 6, so 2 ones are 2, 3s are 6. So 3 into 3 is 9. So 9 plus 2. 9 plus 2 divided by 6. So you should actually solve this particular fractions. So I have already taught you how to solve the rational numbers, addition of rational numbers. So you should take LCM of denominator, and then you should multiply with the individual terms, and whole should be divided by LCM. So now I have got 9 by 2, 9 plus 2 divided by 6. So here the answer will be 11 by 6. So when you write in the form of LHS, you are getting answer as 11 by 6. When you write in the form of RHS also, you are getting the answer as 11 by 6. So that shows 1 by 1 plus of 1 by 2 plus 1 by 3 is actually equal to 1 plus 1 by 2 inside bracket plus 1 by 3. That means these particular rational numbers are actually satisfying a plus b of b plus c is equal to a plus b of plus c. So this particular equation is satisfied by rational numbers, because you are getting 11 by 6 and 11 by 6 like same answer when you write in the form of LHS and RHS. So this particular equation is satisfied for this particular rational numbers. So associative property under addition for rational numbers is satisfied. Similarly, you can test associative property under subtraction for this particular rational numbers. So here also you can take 1 by 1, 1 by 2 and 1 by 3 as your examples. That should actually obey. A minus of b minus c is equal to a minus b of minus c. So this particular equation should be obeyed. So you can test whether associative property for under subtraction for rational numbers will be satisfied or not. So for your information, I am telling you that rational numbers, associative property under subtraction for rational numbers will not be satisfied. So now let me only solve for associative property under multiplication for rational numbers. So quickly I will just solve this. So let us take 1 by 2 and 1 by 3 as three examples for rational numbers. Here for multiplication it should be a into b into c, where b and c should be inside bracket, should be equal to a into b of into c. So this particular equation should be satisfied for multiplication. So 1 into 1 by 2 into 1 by 3 will be equal to 1 into 1 by 6. So that will be equal to 1 by 6. So similarly, if you write in the form of RHS, 1 into 1 by 2, 1 by 3 will be outside. So 1 into 1 by 2 will be 1 by 2 into 1 by 3. So 1 by 2 into 1 by 3 will be 1 by 6. That shows this LHS and this particular RHS. Like if you write in the form of LHS and RHS, you're getting these two as equal. So this particular equation is satisfied. Hence associative property under multiplication for rational numbers is actually satisfied. Similarly, if you check for division, it will be not satisfied. So you can test that. So associative property under division for rational numbers. So if you consider 1 by 2 and 1 by 3 as your three rational numbers, so it should actually we should actually check whether this particular condition is satisfied or not. A divided by of B divided by C is equal to A divided by B of divided by C. So this particular equation should be solved. So let us test whether these three rational numbers are satisfying or not. So 1 divided by 1 by 2 and 1 by 3 will be inside bracket. So now to solve this, you can actually interchange this division with multiplication, and you can actually interchange numerator and denominator of the second number. So that will be 1 divided by 1 by 2 into 3 by 1. So now you can solve this. So 3 into 1 3, 2 into 1 2. So now it will be 1 divided by 3 by 2. Now again you can change this division symbol into multiplication symbol, and you can interchange this numerator and denominator. So it will be 1 divided by will become into multiplication. So 1 into 3 by 2 will become 2 by 3. So the answer which you are getting is 2 by 3. So similarly, if you write in the form of RHS, you will actually get 1 divided by 1 by 2. Outside bracket you will be having 1 by 3. So now you should solve inside bracket. So 1 divided by 1 by 2 can be written as 1 into 2 by 1 divided by 1 by 3. So now again you can change this division into multiplication, and you can interchange the numerator and denominator of this. You can solve this also. So 2 into 2 by 1 into 2 by 1 will be 2 into 1 by 3 will become 3 by 1. So 2 into 3 will be 6. So when you write in the LHS form, you are actually getting 2 by 3 as your answer, and when you are writing in the RHS form, you are actually getting 6 as your answer. So that shows 1 divided by 1 by 2 divided by 1 by 3 is not equal to 1 divided by 1 by 2 of divided by 1 by 3. So that means associative, this particular equation is not satisfied by rational numbers. So associative property under division for rational numbers is not satisfied. So coming to the conclusion part, associative property for rational numbers under addition is actually satisfied. Under subtraction is actually not satisfied. Under multiplication it is satisfied. Under division it is not satisfied. So associative property under addition and multiplication is satisfied for rational numbers, but associative property for subtraction and division under subtraction and division for rational numbers is not satisfied. So now let us see what is additive identity for rational numbers. So additive identity means there will be one particular identity or one particular number. Even after adding that number, the result of that particular rational number will be same. So and only number which is possible to satisfy this additive identity is 0, because when you add 0 to any rational numbers, you will get the same answer. So 0 will be the additive identity. For example, let's say 1 by 3 is actually one rational number. So now if you add 0 for this 1 by 3, again you will get the answer as 1 by 3. So now even if you add this 0 to the left of 1 by 3, that is 0 plus 1 by 3, again you will get the answer as 1 by 3 itself. So how much ever times you add this 0 on whichever position, you will get the same answer. So even for this rational number, additive identity is 0. That means if a particular number is added for a rational number, the same result will be obtained. So now if 0 is additive identity, so when you add 0 to any rational numbers, you will get the same answer. So such kind of numbers are known as additive identity, and here for rational numbers, additive identity is 0. Even for whole numbers, even for integers, even for natural numbers as well, additive identity is 0. Now let us discuss what is multiplicative identity. So there is one more term called multiplicative identity. So here also there will be one particular number or identity which if you multiply with any rational numbers, the result of that rational number will not change. The value of that particular rational number will not change. So such kind of number will be the multiplicative identity for that rational numbers. So here only number which is possible to become multiplicative identity is 1, because when you multiply 1 with any rational number on both left hand side or right hand side, you will get the same value. That is, for example, if you are considering 4 by 5 as your example for rational number, so if you multiply this 4 by 5 with 1, you will get answer as 4 by 5 itself. So similarly, if you multiply this 1 by the left hand side of this particular 4 by 5, that is 1 into 4 by 5, again you will get answer as 4 by 5. So how much ever times you multiply this 1 with 4 by 5 or any rational number, you will get the same value. You will get the same rational number. That means rational numbers value will not be changed if you multiply that particular rational number with 1. Hence, multiplicative. That means that particular identity which is even after multiplying, it's not altering the the rational number, the value of rational number. So such kind of number will be multiplicative identity. So for additive identity, 0 was the additive identity. For multiplicative identity, 1 is the multiplicative identity of rational numbers. Even 1 is multiplicative identity for integers, natural numbers and whole numbers. So even for rational numbers, multiplicative identity is 1. Now let us discuss distributive property of multiplication over division, over addition for this particular rational number. So the equation for this distributive property of multiplication is A into B plus C should be equal to A into B of plus B into C. So if this particular equation is satisfied, then rational numbers are actually satisfying this distributive property. So let us write in the form of LHS. So LHS is actually of that particular equation is actually A into B plus C. So now we have 1 by 2, 1 by 3 and 1 by 4. So let us substitute that in this particular A, B and C. So 1 by 2 into 1 by 3 plus 1 by 4. So first you should solve inside bracket according to BODMAS rule. So 1 by 3 plus 1 by 4, to solve this you should actually take LCM of 3 and 4. So LCM of 3 and 4 will be 4 3s are 12. So 12 is the LCM. Now you can substitute that LCM and you can actually solve this particular fraction. So the answer which you get after solving this particular fraction is, you will get 3 1s are 3, 4s are 12. So 4 plus 3 divided by 12. So 4 plus 3 divided by 12 will be the answer. So when you solve this, you will get 4 plus 3 is 7. So 7 by 12. So 1 by 2 into 7 by 12. So when you solve this, you will get 7 divided by 24. 12 2s are 24. Now the answer for this particular LHS is 7 by 24. So here the equation for this distributive property is A into B plus A into C, not B into C. It is actually A into C. So A into of B plus C should be equal to A into B plus A into C. So now we have actually taken 1 by 2, 1 by 3 and 1 by 4 as our rational numbers, and we have solved for LHS part of this, that is A into B plus C. So we have solved B plus C and we have got it as 7 by 12. So 1 by 2 into 7 by 12. So that is 7 by 24. So now we have actually solved the LHS part of this particular equation. So now let us look at the RHS part of this particular equation, that is A into B plus A into C. So A into B, RHS is equal to A into B, that will be in bracket, plus A into C, that is also there inside bracket. So now you know A is actually 1 by 2, B is actually 1 by 3, plus A is actually 1 by 2, C is actually 1 by 4. So now if you solve this, you will get 1 by 2 into 1 by 3 is 1 by 6, plus 1 by 2 into 1 by 4 will be 1 by 8. So now if you solve this 1 by 6 and 1 by 8, so you should take LCM of 6 and 8. So 2 is the common term. So 2 3s are 6, 2 4s are 8. So now you have got 4 as your answer. So 2, 3. So 2 into 2, 2 into 2. So that is 8, 8 into 3. So 8 3s are 24. So 24 is the LCM for 6 and 8. So now if you multiply this 24 with this 1 by 6, you will get 6 1s are 6 4s are 24. So 6 4s are 24. 8 3s are 24. So divided by 24 LCM. So when you solve this 1 by 6 plus 1 by 8, you will get 4 plus 3 divided by 24. So 4 plus 3 is 7 divided by 24. So now you can see when you solve this LHS part, that is A into B plus C, you got answer as 7 by 24. Similarly, when you solve this RHS part, that is A into B plus A into C, again you got 7 by 24. So this actually shows LHS is equal to RHS. That means A plus of A into B plus C is equal to A into B plus A into C. So that shows this particular rational numbers 1 by 2, 1 by 3, 1 by 4 is actually obeying this particular equation. That is 1 by 2 into 1 by 3 plus 1 by 4 is equal to 1 by 2 into 1 by 3. So that is there in bracket plus 1 by 2 into 1 by 4. So this particular equation is satisfied by these rational numbers. Hence distributive law of rational numbers. So that is this distributive law of multiplication over addition is actually satisfied for this particular rational numbers. Coming to the exercise part in this particular rational numbers, you have exercise 1.1, out of which coming to the first question, so they have asked 3 questions in this particular first question, and they have actually told to name the properties which are used in this particular questions. So coming to the first question in this particular first question, so they have actually given minus 4 by 5 into 1 is equal to 1 into minus 4 by 5, that is equal to minus 4 by 5. Here actually they are actually multiplying minus 4 by 5 with 1. So again they are getting the same answer. So here this is actually commutative property under multiplication, and even this can be written as multiplicative. Here 1 is actually acting as multiplicative identity as well. So here you have multiplicative identity which has got multiplied with this particular rational numbers on both sides, and this is also satisfying this particular equation A into B is equal to B into A, which actually sums up for this commutative property under multiplication. So the first property for this, the property which is obeyed by this first question is commutative property under multiplication, and multiplicative identity is actually used in this particular question. So here also coming to the second question in this particular first question, they have given minus 13 by 17 into minus 2 by 7 is equal to minus 2 by 7 into minus 13 by 17. So here also it is in the form of A into B is equal to B into A. So this is also commutative property under multiplication. So here also commutative property under multiplication is used. Coming to the third question in this particular first question, they have actually asked minus 19 by 29 into 29 by minus 19, so is equal to 1. So whenever a rational number, the inverse of that particular rational number is taken and multiplied with that particular rational number, the answer will be 1, because here minus 19 and minus 19 gets cancelled, 29 and 29 gets cancelled. So let us take another example, 2 by 5. So if you invert this 2 by 5, like if you take inverse of this particular 2 by 5 and multiply with this particular rational number, then it will become multiplicative inverse. So that is 5 by 2. So you are multiplying 2 by 5 with 5 by 2, the inverse of that 2 by 5, and you are multiplying that inverse of that particular rational number. You will get 1. So whenever you take multiplicative, whenever you take inverse of a rational number and you multiply, then that becomes multiplicative inverse. So multiplicative inverse is also satisfied by this particular rational numbers. That means whenever you take inverse of rational numbers and multiply that with that particular rational number, you will get 1 as the answer. Because here minus 19 gets cancelled, 29 gets cancelled. So the property is multiplicative inverse. So coming to the second question, they have actually asked 1 by 3 into 6 into 4 by 3 should be compute as 1 by 3 into 6 into 4 by 3. So which property will allow to make this particular number, like this particular equation, equal to this particular equation? So to make 1 by 3 into 6 into 4 by 3, which is there in bracket, now we are putting the same bracket to 1 by 3 into 6 and 4 by 3 is taken outside bracket. So which property is applied to make these two equal? So here actually distributive property under multiplication. So distributive property under multiplication is the property which you can use to make these two equal. So here you can see there is 1 by 3 outside the bracket. Here 1 by 3 and 6 are inside bracket and 4 by 3 is outside bracket. So these two will become equal only if these are satisfying distributive property under multiplication. So property which they have asked in this particular second question is distributive property under multiplication. So this is the answer for second question. So coming to the third question, they have asked a fill in the blank where they have mentioned product of two rational numbers will be a rational number. So product of two rational number will again be a rational number. So answer for this third question will be rational number. So you should write rational number in that blank. So this is all there in this particular video. So this was the part 2 of rational numbers chapter. Similarly, I have made part 1 of rational numbers. So you should go through part 1 and then you should go through this part 2 video to understand rational numbers in a proper manner. So like this, I will be uploading more and more physics, chemistry and mathematics videos starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel and stay tuned with my channel. Thank you.